we want to determine the number of terms of this sequence. So we have several of the first couple of terms, and then we have the last term. So remember, when we're finding the number of terms in a sequence, we use the letter n to denote the number of terms. So we're really trying to solve for n here. So let's begin with the pattern. How are we going from one term to the next? It appears that we're subtracting 3 each time in this case. We're subtracting 3 repetitively, which is the same as adding -3. So this tells us two things. First, it tells us that our sequence is an arithmetic sequence. That's the type of sequence we have. And we also know, since it's arithmetic and we're subtracting 3 repetitively, that our common difference is -3. So with the information we have right now, we can write a general formula for this sequence of numbers. We call it a general rule. A sub n is equal to the first term, which is a sub 1, plus n minus 1 times d. This formula was derived in a previous video, so we're just using it in this example. Our first term is 2, plus n minus 1 times d, and d is -3. Now remember, it's super important that you have the -3 in parentheses, because if you forget those parentheses and you just have n minus 1 in parentheses minus 3, this is going to look like subtraction, that we're subtracting 3, which is not the case. So be careful and be sure you have that common difference in parentheses there. Now let me mention, you do not have to use this formula. There are many people that can figure out the general rule without using the a sub 1 plus n minus 1 times d formula, and that's perfectly fine. So if you're a person that recognizes that we have this repetitive addition, we're adding -3 repetitively, therefore we could write this as -3 times n. Another way of thinking of it is a linear relationship. So this -3 is really our change. So this is our slope each time. And then you just have to think about what value would I add or subtract to adjust this formula so that I get 2 as my first term. In other words, I want to be able to plug in 1 for n, and therefore I want to get out 2 as my first term. So what value would I add to -3 here so that I end up with 2? And that value would be a positive 5. -3 plus 5 will give me a positive 2. So that tells me my formula then would be -3n plus 5. So remember that these two general rules, the one I have here, 2 plus n minus 1 times -3, and this one here, -3n plus 5, these are equivalent. They're the same exact expression, the same formula, just written in two different forms. So I'm going to demonstrate how to use both, so you can choose which one you like. Now we're looking for n, we're trying to solve for n, so we need to use the fact that we know the last term here is -22. So we're going to substitute that in for a sub n, our last term. And again, it doesn't matter which version you're using, if you're a person that was using the formula or you developed the formula on your own. And essentially now you're just solving this equation for n, the number of terms. So in this case, we would subtract 2 from both sides. So -24 equals n minus 1, the quantity n minus 1 times -3. Dividing by -3 would give us 8 is equal to n minus 1. And then adding 1 would give us n is equal to 9, which means that we have 9 terms altogether in this sequence. And if you're a person that was using the general formula a sub n equals -3n plus 5, notice how you will still get the same exact answer. By subtracting 5, you have -27 equals -3n, and dividing by -3 will still give you n is equal to 9. There's 9 terms. And before we move on, let's mention, many people say, why bother using a formula? I could just subtract 3 over and over again, and I could just count. I could even count on my fingers for this one, and eventually I would count that I'd have to do this 9 times to get down to my answer, essentially, to -22. But I would remind you that if that last term, negative 22, let's say it had been something really, really, really small or very, very, very big, because maybe there were like 110 or over 1,000 terms in the sequence, it would not be very efficient to add or subtract repetitively and try to count. It would be much more efficient to use a formula to determine the number of terms. So a general formula ends up being very helpful and efficient, especially when you have sequences with a lot of terms.